Viewers, you are welcome to this nursing exam prep tutorial. So in today's tutorial, we shall be looking at radicals. Okay, then we also look at how to find the valency of a radical. But let's start with a radical. What is a radical? A radical is a group of atoms. It's a group of atoms acting together. A group of atoms acting together as a single entity. Group of atoms acting together as a single entity. Okay, so let's look at the examples of radicals, symbols, and their valencies. We have radical there, then here we have symbols, and here we are going to have valencies. Okay, now the first radical I'm going to mention here is diisonitrate 3 ion. Diisonitrate 3 ion. Now the symbol of this radical is NO2 is an ion. Ion has positive or negative charge. So the valency of this radical is 1. We are going to see how this radical has valency of 1 later. Then the second radical is triisonitrate 5 ion. Triisonitrate 5 ion. Triisonitrate 5 ion. Now the symbol for this radical is NO3, and it has a negative ion, and the valency is 1. We have another radical, which is tetraososulfate 6. Tetraososulfate 6. Sulfate 6 ion. They are all ions. So the symbol for this is SO4 2 minus. So the valency is 2. Now I will mention another radical, triisocarbonate 4. Triisocarbonate 4. Triisocarbonate 4 ion. The symbol is CO3 2 minus, and the valency is 2. Then we have triisophosphate 3. Triisophosphate 3 ion, which the symbol is PO3 3 minus. So the valency is 3. And we have tetraosophosphate 5. Tetraosophosphate 5. Phosphate 5. ion. The symbol is PO4 3 minus, and the valency is 3. All right, so now these are examples of radicals, their symbols, and their valencies. Now the next thing I'm going to take you through now is how to find valency of a radical. So I'm gonna wipe this off. How to find the valency of a radical. So how do you find valency of a radical? I'm going to make it very precise. So let's look at this radical NO2. NO2. Now, how do you find the valency of this radical? Now, this is what you do. Now, if you look at this radical, we have 1 nitrogen and we have 2 oxygen. So I want you to split this oxygen atom, like O here, and we have another O here. So that gives us the 2 oxygen we have there. So now the next thing you are going to do is this. You are going to consider the atomic numbers of these elements. Consider the atomic numbers of these elements. Nitrogen, this nitrogen has atomic number of 7. Oxygen has atomic number of what? 8. This is also 8. So now you configure these elements. Configure this element by using the N shell notation. So we know that this K shell usually occupies 2 electrons. So this nitrogen will be like 2. Then if you take away 2 from 7, you are going to have 5. Okay, so this 2 goes to the K shell, this 5 goes to the L shell, and this K shell takes a maximum of 2 electrons. L shell takes a maximum of 8 electrons. This takes a maximum of 8 electrons as well. So if you look at this L shell, you see that the electrons that are supposed to fill this L shell is not complete. Okay, so I will show you what to do with that. Now configure this oxygen 2 here. Now when you take away 2 from 8, you are going to be left with 6. Now we also have another oxygen here, so we have 2, then we have 6. Now our aim is to make sure that these oxygen atoms are completely filled, like the outermost shells are completely filled. So what do we do? Now these 5 electrons that are left on the outermost shell of this nitrogen, we are gonna pick 2 and drop it to this 6. So that will be 6 plus 2 to complete the outermost shell of this oxygen. Now do the same thing. If you pick 2 out of 5, you are going to be left with 3. So you pick another 2 and give it to this guy here. So you see that these 5 here will be left with 1. After we have taken 2 here, take 2 here. So now that shows that this radical has a valency of +1. It has a valency of +1 because this 1 that is left can be given out. And when you give out electron, you become positively charged. But because this radical, this NO2 is a gas, NO2 is a gas, so its ion will be negative because it is a gas. Then this ion will be negative. It will not be positive. Okay. All right. So now let's let me give you another example. Let's say we have NO3. This is the radical. Now we want to find the valency of this radical. So by following this method, you have your nitrogen. Now here we have how many oxygen? We have 3 oxygens there. So you displace your oxygen there. Now you go by configuration. configure them. This is nitrogen. Nitrogen has 7 electrons, so you put 2 on the K shell to remain 5. Put it here. Then this oxygen, by configuration, we put 2 on the K shell, put 6 on the L shell. Then here we have 2 on the K shell, 6 on the L shell. 2 on the K shell, 6 on the L shell. So now what do? Our aim is to completely fill the oxygen atom. So now here we are going to pick 2, add to this 6, pick 2 here, add to this 6. Now we are left with 1. So that one, we'll pick that one and come here and add to this 6. Now this guy here is not complete because 6 plus 1 will give us 7. So we still need 1 electron to complete that shell. So we are gonna go to borrow 1 electron, and when you borrow electron, you become negatively charged. So that means if we borrow 1 electron, that shows that this radical has a valency of minus 1. So that valency has, the radical has a valency of minus 1. Okay, do you need more examples? Okay, I'm gonna give you 2 more examples, then call it a wrap. All right, now let me give you this. Let's take this radical SO4, that is tetraoxo sulfate 6 ion is a radical. So we want to find the valency of this radical. Okay, so we are still gonna use the method we are using. We have 1 sulfur here, so you're gonna display your sulfur. We have how many oxygen here? We have 4 oxygen, so we display our oxygen like this. Okay, I hope that is simple. Okay, so now what's the atomic number of sulfur here? Sulfur is 16. Yeah, sulfur is 16. So we are gonna configure this sulfur by putting 2 on the K shell, 8 on the L shell. Now we'll be left with 6. So we take that 6 to the M shell. Then we configure our oxygen, 2 on the K shell, 6 on the L shell. The same thing here, 2 on the K shell, 6 here. Okay, 2 here and 6 here. 2 here and 6 here. All right, so now what do? Now our aim is to make sure that this oxygen atom, the outermost shell, are completely filled. So we have 6 on the outermost shell of this sulfur. So we are going to distribute these 6 to these uncompleted shells of this oxygen. So if I add 2 here, that one is complete. Add 2 here, that's complete. 2 plus 2 is 4. We are still left with 2 there. So we add 2 here. So that has completely filled these 3 oxygen. So we are left with this guy here. This guy is not filled up. So we need to go and borrow 2 because these valence electrons of this sulfur has been used up. So we need to go and borrow 2 electrons to complete this guy here. So by borrowing 2, we have minus 2. Remember, when you borrow, it is minus. When you give out, it is plus. Okay, like I said, I promise that I want to give you 2 more examples. So this is 1. So I will just give you 1 more example. Okay, so now let's go with this radical PO4 minus. This is a radical. Okay, this is a radical tetraoxo phosphate 6 ion. So now by want to find the valency of this, we have phosphorus. Okay, and we have 4 oxygen, so you display your oxygen atoms. Okay, are you getting it? All right, so now what's the atomic number of phosphorus? That is 15. So by configuration, we have 2 on the K shell, 8 on the L shell. We'll be left with 5 on the M shell. So as usual, oxygen is 2 here, 6, 2 here, 6, 2 on the K shell, 6 on the L shell, 2 on the K shell, 6 on the L shell. All right, so now we are gonna distribute this guy here. So I drop 2 here, drop 2 here. We are left with 1. So if I drop that 1 here, this guy is not complete because 6 plus 1 will be 7. We still need 1 to complete this guy. And this guy here is not complete. We need 2 to complete this guy. So if you look at this, we have borrowed this 1 to complete that guy there. Then we borrow 2 to complete this guy. So altogether, we have borrowed what? 3. So the valency is -3. So that's how you can find the valencies of radicals. See you next time in our next video. If you have not subscribed, remember to subscribe for more videos. Thank you very much.